So tougher related rates problems, just like the last problem we did on practice and the last problem on your quiz, the key is understanding your fixed quantities and understanding your fixed relationships. Having something that's always true allows us to manipulate our original formula to make it easier to work with. Okay, that's key. Most of these problems that we're about to do will also have extra steps because we'll have some missing values. If we have missing values, don't worry, but maybe try to do a little bit of extra work to find the missing value given your original formula or given the information that you're given. Okay? Let's start with kind of the type of problem we ended with that we saw today. A cylindrical tank is losing water at a rate of 10 cubic feet per minute. If the radius is 10 feet, how fast is the height of the water changing? You should be able to do this. This is just like a review, but it's also starting to make sure we understand. Understanding the fixed quantities is super important. The volume of a cylinder is pi r squared h. You'd be given that. Told dV dt is 10. We're losing water, so the change in volume is decreasing, so the change in volume would be negative. Radius is 10. How fast is the height of the water changing? Knowing that this is always true, this is a fixed value. We could take that, plug it into my original formula, having a formula for the volume of my water, which is pi times 100 h. This is much easier to work with. Take the derivative of this. Plug in dV dt, solve for dH dt. This is the exact same problem we did in practice, I think. It's a height, so it'd be units to the first power. Okay, next one. Growing rectangle that has a length that is twice its width. How fast is the perimeter growing if the width is growing at 5 centimeters per second? Write down all the information. Write down the formula you think you're going to use. This is most of the battle, is getting everything down. So go ahead, get everything down. Use your brains right now. Get your information down for that guy. The length is twice the width. How fast is the perimeter growing? If the width is growing at 5 centimeters per second. We have the information down, but we're trying to find how quickly the perimeter is growing. You guys need to be able to write down the formula for the perimeter of a rectangle. If you haven't done so, do it now. Check with your neighbors. See if our perimeter is the same. All right, good. 2L plus 2W. Now, again, the key to these tougher problems, before we take the derivative, there are other ways to do this. This is what I would recommend. What we have here is a fixed relationship. The length is always twice the width for this specific rectangle. So yes, the perimeter of a rectangle in general is 2L plus 2W, but we can create a new formula for the perimeter of our rectangle. Replace L with 2W. We get P equals 6W. Take the derivative. dP dt equals 6dW dt. Width is growing at 5. dP dt equals 30. Perimeter is just a length, so it'd be in units to the first power. Okay, so this problem's tricky if you don't know the formula of a perimeter, if you did not replace things, if you did not write your information down, you know, all this stuff you kind of need to practice. Next one. Again, we'll be dealing with something that is fixed, and this problem will introduce us to the extra step that we've done before, but like 2 classes ago. So let's see, we got a pile of sand. We're going to assume it's a conical pile of sand. It's being formed by a conveyor belt that is adding sand at a rate of 5 cubic feet per minute. The radius of the sand pile is 3 times larger than the height of the sand pile. How quickly is the height of the pile changing when the radius is 4 feet? You'll be given the formula for the volume of a cone. It's 1/3 pi r squared h. Now, again, and again, and again, this could be a very tough problem if we just wrote our information down and then took the derivative of v. But it will be easier if we know that this is always the relationship of the radius and the height of our sand pile. This is fixed. Because it is fixed, it can be placed into our original formula to create the formula for the volume of our sand. Okay, the 3h squared becomes 9h squared. The 9 times the 1/3 becomes a 3. H squared times h is h cubed, so that simplifies to that. So after you simplify, you're ready to take the derivative. Look to simplify before you take the derivative. This is a much nicer formula to work with because I do not have to use the product rule. I only have one variable on the right side. Let's go ahead and take the derivative. Sorry, I forgot to write down that dV dt is 5. All right, so I plug in 5, I get 9 pi, but I don't see what h is. Yep. Radius is 3 times larger than the height. It looks like this radius is 4. I got the radius is 4. I don't know what h is. It wasn't given to me. Well, this is introducing us to the extra step. There may be some questions where not all of the information that we're going to use is given to us, but we can find all of the information that we need. So, extra step, we want to find h when r is 4. That's one thing I'm given. Well, we're given the relationship between r and h. R is 3h. When r is 4, h has to be 4/3. All right. We found h. Now we can finish off and solve. We'll pause there. All right, let's get into some tougher related rates. Keeping in mind, fixed relationships, very important. Fixed values, very, very important. Also, we may have to do an extra step to find missing information, okay? We are going to now move into situations where it appears formula is not given to us. Person is watching the space shuttle launch. The person is 3,000 feet from the launch pad. How fast is the distance between the person and the shuttle changing when the shuttle is 4,000 feet high and rising at a rate of 800 feet per second? Well, it's like we don't have a cylinder, we don't have a square, we just have a situation. Sometimes it helps to draw a picture of the situation. That way we know what's kind of going on. So I got a guy who is 3,000 feet from a launch pad. We got a shuttle going up in the air. There we go. And we have a distance between the person and the shuttle that is changing. What kind of picture did I just draw? What shape? Yeah, right triangle. Because we have a right triangle, we are going to use our friend, the Pythagorean Theorem. X squared plus y squared equals d squared. We're going to label horizontal distances as x, vertical distances as y, angular distances as d. So the person is 3,000 feet from the launch pad. I'm going to label that as an x. How fast is the distance between the person and the shuttle changing? That is this angular distance, d. And I'm trying to figure out dt. When the shuttle is 4,000 feet high, so that's y, and rising at a rate of 800 feet per second, so the shuttle is going up, that'd be the change in y, dy dt. Okay? Well, discuss with your neighbors, what is fixed in this scenario? Sure. The x, person is standing still. The launch pad is 3,000 feet away. This is always 3,000. Since that is always 3,000, yes, the Pythagorean Theorem, x squared plus y squared equals d squared is what we're going to use, but instead I can use 3,000 squared plus y squared equals d squared. Now, realize the y, not fixed. So I'm not plugging in 4,000 because that y distance is changing. The space shuttle is going up in the air. Okay? But plugging in 3,000 is going to make this a lot easier to work with because I just have 2 variables now instead of 3. And after I've plugged in everything that is fixed, which is just the 3,000, I can't plug in dy dt yet, I can take the derivative. Now what's great about plugging in 3,000 is the derivative of 3,000 squared. What is it? 6,000? Not correct. 0. It's a constant. The derivative of a constant is 0. So that's why it helps to plug in a fixed value. Here, the derivative of y squared would be 2y dy dt. The derivative of d squared, 2d dd dt. And I can get rid of the 2's. Okay, great. Well, let's plug in our information. Now I can plug in 4,000 because I'm trying to find d dt at this moment. At the moment when the y is 4,000, the dy dt is 800. I'm trying to find d dt, but I have a missing piece of information. I don't know what d is. Here comes that extra step again. We ourselves have to find d even though it's not given to us. So I'm going to write down here, extra step. Find d at the moment when x is 3,000 and y is 4,000. Now, what are you going to use to find d? You'll use the Pythagorean Theorem. 3,000 squared plus 4,000 squared equals d squared. You'll find d is just 5,000. It's a 3, 4, 5 right triangle. So that goes in here. Do some calculations. You'll be able to use your calculator on your next quiz as well as on the test, just for some simple calculations. And you'll get 640. It's a distance, so it's in units to the first power per second. Okay? So, dealing with the Pythagorean Theorem. Make sure we understand fixed values. There may be an extra step. Let's look at this guy. A 10-foot ladder stands against a vertical wall. If the lower end is being pulled away from the wall at a rate of 2 feet per second, how fast is the top of the ladder coming down the wall when the top of the ladder is 6 feet above the ground? Go ahead and draw a picture and label your picture. Now, there's multiple ways. Don't erase. There's multiple ways you can draw a picture of a ladder up against a wall. The wall can be on the right, the ladder leaning to the right, or the wall could be on the left and the ladder could be leaning to the left. No matter what you do, you'll get the right answer. Okay? I drew it this way. You may draw it another way. All right. Make sure you have labeled the picture and make sure you have signified what is fixed. Okay, so the lower end is being pulled out. Top end is going to be sliding down. How quickly is the top sliding down? Well, I have a question for you guys. dx dt, because this is like x and the distance is changing as I pull it away. That would be me pulling away the ladder at the bottom would be a change in the x. I'm moving to the left. Should this be a negative value since I'm going to the left? People are shaking their heads no, but why? The drawing could be either way, but maybe the other way it should be left too. I mean, it should be negative too. So it's being pulled away, which means what? It's increasing. Beautiful. This x distance is getting bigger. When something is getting bigger, its derivative is positive. So it's not that I'm moving left. That has nothing to do with it. It's that the distance is increasing, so its derivative is positive. So dx dt, no matter how you draw the picture, is positive too. Even though you think I'm moving to the left, it's like, nope, the x length is increasing as I pull the ladder away. Okay, I'm ready to use my Pythagorean theorem, x squared plus y squared equals d squared. But I forgot to do one thing. Label what's fixed. What is always going to be the same? D, the ladder's length. Okay. You should be able to plug in D, take your derivative, and solve. You may have to do an extra step to find a missing piece of information. Well, if we have a 3, 4, 5 right triangle, we'll have a 6, 8, 10 right triangle. But go ahead and give it a shot. Make sure you note that the y equals 6 is not fixed. So don't plug it in until you're trying to find dy dt. Help yourself out. Get rid of the 2's when you're taking the derivative of the Pythagorean theorem. You just have x dx dt plus y dy dt equals 0. Make sure we note that the derivative of 10 squared is 0. I'm ready to plug in my information. Dx dt, 2. Y, 6. Trying to find dy dt. Don't forget the equals 0. That way you solve an equation rather than just throw stuff around and put an equal sign randomly. I'm missing information. I'm missing the x. This is the extra step. going to find x when y is 6 and d is 10. X squared plus 6 squared equals 10 squared. You'd end up with x squared is equal to 64. X is equal to plus or minus 8, but we're only talking about positive distances here. So this is 8. Solve. I get negative 16 over 6, which is negative 8/3 feet per second. Have everybody catch up to you there. I got a value that's negative. Do I feel good about the fact that it's negative? Why? The y's are decreasing. In this case, I'm going down, but it's not because I'm going down. It's because the y distance is decreasing. And since the y distance is decreasing, its derivative should be negative. Okay? All right, great. I'm going to set the next one up for you because if I asked you to draw it, you probably wouldn't draw it correctly. Okay, we got a fisherman sitting on a dock. Here is my dock. Here is my fisherman. Here is his fishing pole. And he is reeling in a fish. Here is the fish. And the fish is skimming on top of the water. So here's the water. The fish is at the top of the water, and he's going horizontally on top of the water. That's important. Okay, this is why I draw it, so that you know that he's not coming up angularly. He's coming up. He's coming over. He's sliding over. Okay, this reel is 6 feet off the water. The fish is skimming at the top of the water. Okay, so again, this is why I'm doing this for you, because I was about to mess it up. He's sitting on the top, on a dock. His reel is 6 feet off the water. He's reeling in a fish that is skimming on top of the water at a rate of 1 foot per second. So the fact that he's reeling in the fish at 1 foot per second does not mean the fish is moving across the water at 1 foot per second, but that this is -1. The line, the fishing line, is coming in. Now the question is, how fast is the fish moving along the water when the fish is 6 feet away from the dock? Let's just say it's 6 feet away from this reel. So the question is, what is dx dt when x is 6? Okay, label what is fixed, label what is not fixed. Start with your Pythagorean theorem, plug in what is fixed, take the derivative, and let's find dx dt. I plugged in 6 for y, because that y distance is fixed. I'm ready to take my derivative. I get 2x dx dt plus 0 equals 2d dt. Do yourself a favor. Get rid of those 2's. X is 6. I'm trying to find dx dt. dd dt is -1. But I have a missing piece of information, d. Let's find that missing piece of information. We should be familiar with 45, 45, 90 right triangles from our unit circle. So if this is root 2 over 2, and this is root 2 over 2, this is 1. How do you turn a root 2 over 2 into a 1? You multiply it by root 2. You might be familiar with the right triangle listed as 1, 1, root 2. So if these values were 6 and 6, this would be 6 root 2. You can find the same thing using the Pythagorean Theorem. I'll show you. Here's the extra step. Finding this missing information. I'm going to find d. Find x and y are 6. 6 squared plus 6 squared equals d squared. 36 plus 36 is 72. So d is root 72. 72 can be written as 36 times 2. This is root 36, root 2. So this is 6 root 2. Okay, and now we solve for dx dt. It would end up being negative root 2. Yeah, good point. So the fish is moving left, but that doesn't matter. The fact that the x distance is decreasing means its derivative is negative. The question is, how fast is the fish moving? I'd accept negative root 2 or positive root 2. Fast is the speed. Speed would be the absolute value of your velocity. Okay, great. Let's make these tougher. Same 3 situations. Space shuttle, ladder, fish. Let's figure out how quickly some angles are changing. All right, let's recreate the space shuttle launch again. Here is my dude. My dude is 3,000 feet away from space, from a launch pad. Space shuttle going up in the air. You have, 3,000 feet. How fast is the angle of elevation? Okay, so this is the angle of elevation there. From the ground up is an angle of elevation. Changing between the two, and the shuttle is 4,000 feet high, and again, rising at a rate of 800 feet per second. Okay. So, how quickly is the angle changing? How quickly is that angle changing at this moment in time? That's d theta dt. Well, can't use the Pythagorean theorem anymore because I got x's and y's and d's. I need some sort of equation, some sort of formula with an angle. This is where we use our friend Mr. Sokotoa. This is going to give us an equation with an angle in it. Now, it's important to know that we got three options. We could use sine, we could use cosine, we can use tangent. And you could use all three. However, one is going to be the best one to use given the certain question that we're dealing with. Okay? We need to pick the best one. And we're going to pick the best, not just based on how we feel about them, but based on the information that's given to us, what is fixed and what the d blank dt is. In this situation, the x equals 3,000, this is fixed. So you should be using a trig function with this horizontal side, this adjacent side relative to my angle. The other thing that's given to us is the dy dt. This is considered fixed. It's always going to be 800. So that means we should be using something that deals with y's, or the opposites. Which trig function would be best in this situation? Tangent. Okay. Well, we will write the equation, the tangent of an angle equals the ratio of the opposite side over the adjacent side, or the y over the x. And just like all the other ones, we should plug in our fixed value. We are now ready to take the derivative of this equation, this formula. How many of us remember the derivative of tangent? What is it, Mr. Michaels?
We do it from this way, it's fine, but that's how you find the angle.
Yes, what is the derivative of tangent, though?
Oh, do
you remember? No, we're not going to do that. We're not going to use the inverse tangent. We could, but we don't know its derivative. Secant squared. Secant squared. But it's not just secant squared theta. Nope. I'm missing something from the left side. D theta dt is what I'm missing. So we're taking the derivative of the angle, so we need the d variable dt. Okay, equals. On the right side, we may think, oh, that's a quotient. I should use the quotient rule. But I could write this as 1 over 3,000 times y. And if I asked you what is the derivative of 3y, you would say it's 3 dy dt. If I asked you the derivative of 1/3 y, you'd say it's 1/3 dy dt. If I asked you what is the derivative of 1 over 3,000 y, you'd say it's 1 over 3,000 dy dt. Okay, great. We're trying to find d theta dt. Thank goodness it's right there. I have dy dt. It's 800. But I got something that seems very, very daunting that is missing. What is secant squared? Okay? Of theta. Here's our extra step. It's actually not that hard. I know that secant squared theta is the same as 1 over cosine theta, either quantity squared or just the denominator squared. Doesn't matter. Now, remembering my work I did from the first time we encountered this problem, that x was 3,000, y was 4,000, d was 5,000. Just using the Pythagorean Theorem, I got all three of my sides at this specific moment in time. Well, since I know all three of the sides, I know what cosine of theta is really quickly. Discuss with your neighbors. What's the cosine of theta? No. 3/5. Cosine is equal to the ratio of the adjacent side over the hypotenuse. Cosine of theta equals x over d. What's x over d? It's 3,000 over 5,000, or 3 over 5. That turns into 1 over 9 over 25, which turns into 25 over 9. Voila. Use your calculator, do a little bit of work, and I believe we get like 0.09, I'm not sure. 800 divided by 3,000 times 9 divided by 25. 0.096. d theta dt equals 0.096. We'd call this radians per whatever second. Well, all right. Let's find how the angle between the ladder and the floor is changing. Go. All right, fine, I'll draw the picture. 10-foot ladder up against the wall. Upper end is pulling up, so we're changing a little bit. dy dt is 2. How fast is the angle between the floor and the ladder changing when the top of the ladder is 6 feet above the ground? Please discuss with your neighbors, after getting everything down, what is fixed and what trig function you should use. Go ahead, discuss. What is fixed? What's the trig function we should use? What's fixed? The 6 or the 10? 10, okay. That's not very hard. What else is fixed? The dy dt. It's always going to be 2. Here is my angle between the ladder and the ground. What trig function should we use? Discuss with your neighbors, because I heard very little communication just now. I saw a lot of, I still aren't hearing anything. This should be like easy. Oh, okay, there's theta. I have dy dt and d. So that means I need the trig function that deals with y and d. Which one deals with y and d? Okay, great. Sine of theta equals the opposite over the hypotenuse. I don't like the red. Plug in the fixed value. Go, plug in the fixed value. take the derivative of both sides. Go. Take the derivative of both sides. Yep. If you want to. A 1/10? There's nothing that's undefined.
Well, if you're taking the derivative of 10, wouldn't it become 0?
It's 1/10 times y. And if you wanted to take the derivative using the quotient rule, you'd have the derivative of the top times the bottom minus the derivative of the bottom, which is 0, times the top, all over the bottom squared. You wouldn't be undefined. All right, take the derivative. We should have gotten cos theta d theta dt equals 1/10 dy dt. Plug in the information that's given to you and find the missing piece of information. Go. We kind of have to do two extra things. We have to find the cosine of theta, which means I have to find the x. Remember, to find the x, x squared plus 6 squared equals 10 squared. X gives us 8. So 6, 8, 10 triangle. All right, you think you guys got this down? Let's do the fish problem.
No, bad fishies.
It's one fish. Fisherman is sitting on the dock. Hold on, I did such a good job with my picture before. We got 3 more problems to get through. Where's my guy?
6 feet off the water.
Here we are. Okay, let's go. Recreate the situation. What? There it is.
Why is it DG?
Because he's getting reeled in. So it's the rate at which the reel is changing. 6 feet off the water, reeled in at 1 foot per second. How fast is the angle between the water and the fishing line changing when the fish is 6 feet away? Discuss with your neighbors. What trig function should you use? I got an opposite and adjacent. However, I have this which is fixed and this which is fixed. That's a y and a d. I'm using sine again. You would have thought that Mr. Messer would have picked one of each, but nope, you thought wrong. Oh, things are going to get interesting, gang. Things are going to get interesting. Plug in are fixed. Take the derivative of the left side. Do not take the derivative of the right side because you are all going to do it wrong. Maybe not all of you. But take the derivative of the left side. Just did. Easy. Who can tell me what the derivative of the right side is? If you say it's 6 d dt, you're wrong. If you say it's 6 over d dt, you're wrong. Nope. If you say, well, let's just use the quotient rule, you'd get the right one if you use the quotient rule. However, if you forgot already, and that's okay because we haven't done it in a while, how to take the derivative of something in a denominator, what do? We rewrite it so that it's in the numerator with a negative power. The power rule only works in the numerator. And then we take the derivative to get us negative 6x to the negative third. This I would write as 6d to the negative first. And its derivative would be negative 6d to the negative second, or negative 6 over d squared dd dt. All right, here we go. X is 6, y is 6. Remember d is 6 root 2. Cosine of theta is equal to adjacent over hypotenuse. So this would be 1 over root 2 equals negative 6 over d, again, is 6 root 2 squared. d dt is negative 1. d theta dt would equal, this would be 6 over 36 times 2 times root 2, which is root 2 over 12. Radians per second. Okay? Don't forget this, please. Do not forget how to take the derivative if you have something in a denominator, okay? Because everybody makes mistakes on that. 2 more problems. Guess what? These are the hardest ones. Great. We have a conical tank. It's going to be vertex down. We got water in the tank. The water is being drained out. The volume of a cone is going to be given to you 1/3 pi r squared h. You're told that the tank's radius is 10 and its height is 25. The water is draining out at a rate of 3 cubic inches per second, so dV dt is negative 3. At what rate is the radius changing when the height of the water is 15? Seems like we're back in the world of, oh, this is easy. Just find what's fixed and plug it in. Is the height of the water always 15? No, water's draining out. So the height of the water and the radius of the water are going to be changing. So not fixed. Don't plug it in. So it appears that nothing's fixed. However, there is a ratio. There is something that is fixed, a relationship that is fixed between the radius of the water and the height of the water. And it comes from the fact that I can create 2 similar triangles. One for the water and one for the tank. And we know that with 2 similar triangles, the ratio of their side lengths are going to be proportional. So I can create my own little fixed situation. R over H equals 10 over 25. This is the key to this problem. We have a fixed proportion. That's an H. Okay? All right, great. Well, I want to find dr dt. I don't know which one to solve for. Should I solve for R or should I solve for H? Well, I'm trying to find dr dt. That means I should have an equation with R's, which means I want to take H and replace it with R's, which means I should take this equation and solve for H, so that I had H in terms of R. You get 25R over 10 equals H. That's 5R over 2 equals H. This is fixed. Take this, plug it in here. Simplify. 5, 6 R pi R cubed. Take the derivative of both sides. dv dt equals 15, 6. That's the same as 5 over 2. Pi r squared dr dt. dv dt is -3. But I have another missing piece of information. I don't know what r is. Extra step, find r. You're given h is 15. Five r over 2 equals h. 30 divided by 5, r is 6. This is 6. Solve for dr dt. Times 2 is -6. Divided by 36 is -1/6. Divided by 5, divided by pi, it's like -1 over, no, multiply by 2, -2, no, 1 over 30 pi. Okay, you can use a calculator for that, just include pi in your answer. Pretty nasty, huh? But you'll see this on your quiz and on your test. And you'll see the last one, which is probably one of the hardest if you don't understand what you're doing, one of the easiest if you do. I'm going to go quick with this so that we can get through it. We got a lamp post, which is 20 feet high. We got a dude who's 5 feet tall. Walking away, the lamppost creates a shadow coming off the dude. We have a shadow length, we have an X length. The lamppost is 20, the height of the dude is 5. It says the dude is 10 feet away from the lamp. And he's moving at a rate of 2 feet per second. What shape is created? Right triangle. Your instincts are telling you Pythagorean Theorem. Don't use your instincts here. The key to this problem is the set of similar triangles, which is very similar to the last problem. However, we don't have to use a formula. The formula comes from the proportion that the dude's shadow divided by the dude's height is equal to the distance from the lamppost to the end of the shadow divided by the lamppost height. Now notice, I did not plug in 10 for x because x is not fixed. So I did not plug in 10. Hold on. We can easily cross multiply. Simplify, that's a 5s. Simplify even more. Take the derivative. Plug in dx dt. Solve for ds dt. I would advise you to do these problems again. Yeah. 5/6 to 5/0. Where? Where? Yeah, derivative. Yep.